Very good morning to everyone. Today we are going to discuss the subject kinematics of machinery. In this kinematics of machineries, Unit 1 Simple Mechanism. First, want to know about kinematics. Kinematics is the branch of theory of machines which deals with motion of bodies, points, and system of bodies without considering the force causes the motion. Kinematics of machines, which will deals with study of relative motion between the various parts of the machines without considering the force which will causes this motion of the bodies. Mechanism. The mechanism is the part of machine which transmit motion and power from input point to output point. For example, the mechanism is used for a particular application which is called as machine. The animation video shows the example of a machine. It is a mechanism which will used for some particular application, means it's become a machine. So the cycle also we called as we employed a mechanism to run the cycle. A machine is a approach for applying mechanical power consisting of a number of interrelated ports, each having a definite function, which is called a machine. Every mechanism consists of several parts. These parts are called as bodies. For example, it is classified into three categories. One is the resistance body, next one is the deformation body, flexible body, then fluid body. What is meant by resistance body means it consists of very negligible amount of deformation while transferring the power from one link to another one link. So it is called as what's that? Resistance body. Then flexible body, it consists of, it can able to transmit the power from one link to another one link, but it can able to deform. For example, belts and chains, ropes, these are used to transmit the power from one body to another one body, but it can able to deform. Then next we are going to discuss about the links or elements. Each and every part of the machine or mechanism is called as link or element. So it may be used to transmit motion and power from one link to another one link. It may be a resistance body or maybe a flexible body. This figure shows the example for a link. The mechanism shows slider crank mechanism with a piston and cylinder arrangement, which consists of several links like as piston rod, crossguard, and a connecting rod, and cranks and cylinders. So every part of the mechanism is called as link or parts or elements. The links are classified into three categories. Already we know: rigid and flexible and fluid link. So the rigid link means it can able to transmit the force or power from one part to another one part, but there is no deformation. That means negligible amount of deformation means it's called as rigid link. The practical example: connecting rod and crank and piston. These are the rigid links coming under the category. Next we are going to discuss about the flexible link. The flexible link means it can able to transmit the power or motion from one link to another one link, but it can able to deform. For example, belt and ropes and chains. Fluid link: using the fluid power we can transmit the power from one link to another one link, means it is called as fluid link. So hydraulic systems and pneumatic systems are all working, can able to transmit the power. So these categories coming under the link of fluid. So structure, there is no relative motion between the links is called as the structure, but it can able to transmit the force from one place to another one place, but there is no transmission of motion. For example, trusses and bridges, buildings. These are under the category of structure. The then there is some difference between comparison between machine and structure. The relative motion between the parts is called under the category of machine. There is no relative motion means it will coming under the structure category. Then it can able to transmit the power. That means it getting some power, it will convert into some useful work. The structure will not convert the power into work. It can able to transmit the power from one place to another place. So these are the comparison between machine and structure. The pair is joining of two links we called as pair. The pairs will transmit from one motion or power from one link to another link. So the relative links are called as pair. So pairs are classified under the category of by contact, relative motion and constraint. Based on the contact, it is classified into higher pair and lower pair. So the lower pair consists of point consists of surface or area contact between the two links. It's called as lower pair. Higher pair means point or line contact between two links is under the category of higher pair. Then type of relative motion between the two links, it's called under the category of relative motion. First one is sliding pair, turning pair, rolling pair and screwing pair, then spherical pair. Type of motion between one link to another link under the category. The next category is type of constraint. So two pairs are constrained between them. It is under the category of closed pair and unclosed pair. So they are closed by themselves means it is closed pair. If they are locked by another external source by using a spring or other type of mechanism means it is called unclosed pair. So these are the diagrams for under the category of higher pair and rolling pairs. Next we are going to discuss about the type of constrained motion. Constrained motions are classified into three categories: completely constrained, incompletely constrained, then successfully constrained. So completely constrained motion means the degrees of freedom, that means the movement of a link is entirely constrained by between these two links, means it is called as what's that, completely constrained motion. Incompletely constrained means there is not a definite output coming from this mechanism, means it is called incompletely constrained motion. Successfully constrained motion means it is constrained by external source or external links, that means it is called as successfully constrained motion, coming under the category. So a rectangle slot inside a block, we are moving a rectangle bar inside the rectangle slot means it is completely constrained because of the design of the slot is square, then bar also in the cross section of square, so it can moving only reciprocating motion only. So there is no rotation motion, any other motions are arrested. So it is called as completely constrained motion. In incompletely constrained motion, in a circular slot we can insert a circular shaft, that means it can revolve about its axis, and also linear motion are also possible. So it is coming under the category of incompletely constrained. Then successfully constrained motion means in a vertical bush, inside the bush we have insert a shaft, but it can able to revolve and also reciprocate. If external force acting over the shaft means the linear motion is arrested, it can able to revolve only, so it is successfully constrained by external force, so it is successfully constrained motion. So kinematic chain is joining of number of links such a way that one of the link is fixed, then it can able to transmit the motion and from one link to input link to final link, so it give the definite motion, means it is called kinematic chain. So kinematic chain is how can we define this mechanism is under the category of kinematic chain or not by using Kutzbach criteria. So we have utilizing the formula L equal to 2p minus 4 and J is equal to 3 by 2 L minus 2. Using this formula we can able to find out L equal to number of links, P equal to number of pairs, J equal to number of joints. By using this category, we can able to find the mechanism is kinematic chain or structure we can able to form. The next we are going to discuss about the type of joint. The joints are classified into three categories: binary joint, ternary joint, quaternary joint. Binary joint means we can able to connect two links with a link, means it is called binary joint. If three links can be separately joined with a single link, means it is called coming under the category of ternary joint. If four links can connected with the single link, it is coming under category of quaternary joint. So next we are going to discuss about the degree of freedom. Degree of freedom means number of independent coordinates required to describe a position of your body. It's called as a degree of freedom. So the figure shows single degree of freedom. This consists of only one type, one direction of motion. The figure shows 2 degree of freedom, and cylindrical pair shows the rolling pair shows 1 degree of freedom. So these are the examples of degree of freedom. There's a spherical pair shows 3 degree of freedom. Next we are going to discuss about the inversions of mechanism. Inversions of kinematic linkage or mechanism is observing that the motion of a members of the mechanism with fixing the different links as reference frame. Each time when a different link is chosen as frame is linked, gives different characteristics of motion. So that is called as inversions of mechanism. So first we are going to discuss about the 4-bar chain mechanism. So these are the applications of inversions of 4-bar mechanism: beam engine, coupled locomotive wheel, Watt's indicator mechanism, then pantograph, then Ackermann steering mechanism. So the first inversion is on the figure. That means fourth link is fixed, then first link act as a crank, so the second link act as a coupler, then third link as the follower, it will act as a rocker. So it is a rotary motion is converted into rocker because of first link is shorter, adjoined to the shorter link we have fixing, means we get the crank and rocker output. Same as the second link is fixed, the first link will be rotate about its center, so it is become crank, so output will be getting from link 3 as a rocker mechanism. This is the first inversion. Then the beam engine is under the category of first inversion. Second inversion, the shorter link is fixed, so when the second and fourth link rotate about the fixed points, so one link is act as a input, the another one link is a follower, so what will be happen, it's become rotary motions. So it this inversion called as rotary converter. So coupling rod of a locomotive train wheels is under the category of second inversion of the 4-bar mechanism. Then third inversion shown in the figure, it is rocker mechanism. That means opposite to the shorter link is fixed. So what will be happen means the both the links are fourth and second link, both are can able to rocking motion, creating the rocking motion only, so not able to rotating because of the dimensions of the mechanisms. So the applications of third inversions are Watt's indicator and pantograph, then Ackermann steering mechanism. The figure shows the Watt's indicator, then pantograph, then Ackermann steering mechanism. Next we are going to discuss about the inversions of single slider mechanism, otherwise it is called as crank and slider mechanism. The applications are reciprocating engine, reciprocating compressor with quick return motion mechanism, then rotary engine, crank and slaughter lever mechanism, oscillating cylinder engine, then bull engine hand pump. So in this also the first link is the fixed frame, the second one is the crank, the third one is the connecting rod, then fourth is the slider, which is used for reciprocating engine and reciprocating compressor. Then second inversion, the first link is reciprocate, it can able to reciprocate. Then second link is fixed, as well as third link is act as a crank. So what will happen, the fourth link slide over the first link, so this one is used for without quick return motion mechanism and rotary engine. The figure shows the working of the without quick return motion mechanism. The figure shows the rotary engine, otherwise Yeoman engine. In the third inversion, third link is fixed. The first and like a second link and a fourth link can able to moving. In this inversion is used in the oscillating cylinder engine, crank and slaughter lever mechanism. So the oscillating cylinder will be oscillating cylinder engine will be working in the inversion of 3. Then also crank and slaughter lever mechanism also working under the category of by using the third inversion. In the fourth inversion, the piston is fixed. That means the slider is fixed. The first and second and third link, all the links are can able to move. So this one is used for pendulum pump or bull engine and hand pump. These are used under the using the inversions of the fourth inversions of slider crank mechanism. Next one we are going to discuss about the inversions of double slider mechanism. The applications of double slider mechanisms are elliptical trammel, Kutzbach mechanism and Adams coupling. This mechanism consists of two sliders with a connecting link and then two slots as a fixed gates. So using this you can able to create the elliptical shapes. The second inversion is Kutzbach mechanism. Look, the crank will be rotated about the point A. The slider B can able to slide in the slot of the first link. Also the first link can be slide over the fourth link. So it is coming under the category of double slider. The third inversion is Adams coupling. The Adams coupling consists of one rotary coupling and another one rotary coupling, which are act as a driven shaft and a driving shaft. Then in between that is a flange plate. The flange plate intermediate flange circular plate, it consists of two ribs. Depends upon the size of the ribs. The flange consists of two slots. So in between the two flanges the intermediate plate is fixed. So the both the shafts are eccentrically we have mounted. So we have utilizing this mechanism transmit the power from eccentric axis. Thank you.